Today's lesson is on section 1.4, solving quadratic equations ax squared plus bx plus c by factoring. So there's a few warm-up exercises that you need to do that are to factor the expression. You have a few that are there. And then we're going to move on to example number 1. Example number 1 says factor 5x squared minus 17x plus 6. And this is the first time that we're seeing an equation that we need to factor that has an a value other than 1. So when we look at this, we have our a, b, and c. At this time, we're seeing equations that have a values other than the value 1. So now we kind of need to think of this factoring form a little differently. I'm going to use some more variables just to keep my work organized, but just try to follow along. Kx plus m times Lx plus n. Now, in the video on section 1.3, we used m and n to help us figure out what the b and c value would be after we FOILed our equation. Now we also need to keep into account the k and the l value so that we know what our a variable will be. So this is all because we have this coefficient 5 on our equation. So when I look at this and I think about FOILing, what typically happens is the outer and the inner terms are like terms and they get combined. The first term stays itself. So in this case, my first term is kx times lx. And I know that when I have that, it needs to equal 5x squared. My middle term, my b value, is the combination of the outer terms and the inner terms. So I have k times n plus l times m, and they need to equal negative 17. Lastly, I have my last terms, which is just, in this case, m times n, and that needs to equal positive 6 for my equation to work. So I need to start by figuring out some factors of both k and l and m and n. So for k and l, factors of 5 are just 5 and 1. For m and n, factors of 6 are 6 and 1 or 2 and 3. So now I need to think about combinations of those numbers that will in fact give me that middle term of negative 17. So when I write my fraction, I know I'm going to have 5x times 1x here. And I just need to come up with the second half. So the second half of my equation, one of those numbers is going to have to be negative and one of them has to be positive because that term, negative 17, is a negative number. I'm sorry, and my mn is positive. So actually both of these are going to be negative because a negative times a negative is a positive. So if m and n are both negative, they're going to equal positive 6. But I also need a kn plus lm that is a negative number. So that means that these factors need to turn negative right away. So now I have to just figure out what works. I can say 17 is a pretty large, it's a larger number. I know that 5 times 3 will get me to 15, and 1 times 2 will get me to 2, and 15 plus 2 equals 17. So if I look at that function and I check my work, I should be able to FOIL this now and say 5x times 1x is 5x squared. Outer terms is minus 15x minus 2x, and then plus 6. Minus 15x and minus 2x is minus 17x. So I have the same function I started with, which is exactly what I need. Example number 2 says factor 3x squared plus 20x minus 7. And we're going to do the same kind of thing we did before. I need my k times l to equal 3, and I need my m times n to equal negative 7. And then Km plus Ln equals positive 20. So really, I'm looking at my A value, my C value, and my B value. The B value is definitely the most complicated piece, and I kind of leave that until the end, and I use a guess and check method. There's no exact science to this. I just kind of figure it out. So with the KL, the factors of 3 are 3 and 1. And with the MN, the factors of negative 7 are negative 7 and 1, or negative 1 and 7. I guess for KL, I could also use negative 3 and negative 1 if I really wanted to be specific and not leave anything out. So when I'm looking at my example, I can see how I'm going to set up these parentheses. Already, I know that I need a 3x and a 1x. And in order to get my middle term to be a negative number, but my last term, my middle term to be a positive number, but my last term to be a negative number, I'm going to have a plus and a minus in both of these brackets. I'm going to have a plus somewhere and a minus somewhere. It might be the other way around. It might be a minus and then a plus. I just don't know. But in order to get negative 7, I need a negative 7 and a 1, or a negative 1 and a 7. So in this case, I just plugged in 7 and 1, and I'm going to see how they work. Outer terms, 3 times negative 1 would be negative 3. Inner terms, 7 times 1 would be positive 7. And those two numbers combined do not equal positive 20. So that's not going to work. I could switch my 7 and my 1 and try again. 3 times negative 7 is negative 21. 1 times 1 is positive 1. And so negative 21 plus 1 is negative 20. Well, I got my 20, but it's negative. I want it to be positive. So I'm going to just solidify those signs and say that my 7 should be positive and my 1 should be negative. Now, if I think about it, 3 times 7 is 21. 1 times negative 1 is negative 1. 21 minus 1 is just 20. So I end up with the correct grouping to get that B term to be positive 20. So this factored form is my correct answer because 3x times 1x is 3x squared. Outer terms, 3x plus 7 is 21x. Inner terms, minus 1x would be 20x. And then my last terms, negative 1 times 7 would be negative 7. Example number 3 says to factor the expressions. These have special patterns. They are very similar to what we saw the other day. They're a difference of 2 squares. Both the numbers given are perfect squares. They can just be squared. So I can say 3 minus 8, don't forget your x, and I'm done. Squared. 3x minus 8 squared is the same as 9x squared minus 64. Same thing here. Take the square root of the 4 and the square root of the 25, and I get 2y plus 5 squared. And if I FOILed that out, 2y plus 5 times 2y plus 5, I would get 4y squared plus 10y plus 10y plus 25, which is the same as 4y squared plus 20y plus 25. Those are definitely much simpler than having to break everything down. Example number 4 also says to factor the expression, but we're going to factor the monomials out first. Basically, that means factor out the constants that you can. So in letter A, I have a value 5 in both of those terms. So if I take out that 5 and I say 5 times x squared minus 9, now I'm left with a perfect square. So I've got 5 times x minus 3 squared, and that's my factored form. So basically, first I took out a whole number, and then I used the difference of squares. I can do the same thing for letter B. I can take out a 2. So 2 times 3q squared minus 7q plus 4. And that number should be much easier to factor. So looking at just the piece in the parentheses, I know I'm going to need a 3Q, and a Q. There we go. And then my last term is going to have to be a positive 2. So, and don't forget your coefficient is 2. And that way you can keep working from there. Letter C, I can factor out a 5, but I really can't do much more because I have -5 times z squared minus 4z. I really can't break that down any further because I don't have a c value. So I would leave it right in that form. And the same thing with letter D. I can definitely pull out a 3. But once I do that, I'm left with no c value. So I really can't put that into any simplified factor form. Example number 5, we are going to skip along with example number 6. Those are topics we're going to cover in class. I feel like these are, this particular subject needs a lot of review, so I want to make sure that you get that when you need it. However, I do want you to do your homework quiz. Factor the expressions. You have 3 examples there. Number 4, you can skip. That's an extension of a previous example. So we will cover that in class.